Hello everyone, welcome back to one of the video in my series How to Interclass CSC 120. Today's topic is multiplexers. In this video I'm going to show you about how to design basic multiplexer as known as muxes, how to use muxes as a building blocks to larger one, and how to differentiate between different types of muxes. Let's get started with the very basic multiplexer, the 2-to-1 mux. This multiplexer has two inputs, D1 and D0, and also one selector input S. It has one output Q. The multiplexer is also known as the data selectors, which means that we only select one input to be the output. At the function table on the right side show you the output Q value is based on the value of D0 or D1, and D0 or D1 is selected by the selector input S. If the selector S is 0, then Q would be equal to D0. If the selector S is 1, then the output Q would be D1. From that function table, we're going to derive the function Q equal to S0 times D0 and plus S times D1. This function is implemented by this circuit right here. You can see that in this part, we time D0 with S0, and this one is S times D1, and the two product terms will combine together with an OR gate to get the output Q. Let's test it out. So right now the selector input is 0, which means that we are selecting the value of the D0 to be the output. So Q is 0. If we change D0 to 1, then Q is also 1. If we change the selector input S to 1, it means that we select D1 to be the output. D1 right now is 0, so Q is also 0. If we change the value of D1 to 1, then Q is 1. And the value of D0 doesn't affect the final output of the circuit. And that is our 2-to-1 multiplexer. From the 2-to-1 mux, we can use it as a building block to build larger one, like the 4-to-1 multiplexer right here. In this 4-to-1 multiplexer, I use 3 2-to-1 muxes. This circuit has 4 inputs, from D0 to D3, and also 2 selector inputs, S1 and S0. Since we only have 4 inputs, we need 2 selector inputs to select from these 4 inputs, because 2 bits can count to 4 values from 0 to 3. The function table on the right side shows you how the circuit works. If the value of S0 and S1 is 0, 0, then the output Q is equal to the value of input D0. And the same goes for the rest of the table. I use 3 2-to-1 muxes to build this 4-to-1 multiplexer. Let me explain how it works. For this multiplexer, I choose either D0 or D1 based on the value of S0, and the same goes for the second multiplexers. I choose D2 or D3 based on the value of S0, and this 2-to-1 mux, it chooses the value of either from this output Q or this output Q based on the value of the selector input S1. So for example, if I choose 0, 0, it means that I choose 0 from this part, So I choose D0. I choose D2 from this 221 mux. So I got D0 go out here, and D2 go out here. D2 and D0 go into this 221 mux. And S1 and S0. S1 is 0, I'm sorry. So I'm going to choose the 0 input from this output. So I'm going to have 0. If I change the 0 to 1, then Q is also 1. If I change the S1, S0 to 0 and 1, it means that I'm selecting D1 to be the output. D1 is now 0. Then Q is also 0. Change D1 to 1. Q is also be changed to 1. If I choose 1, 1 for the selector inputs, then Q0 is, no, I'm sorry, Q is D3. So let's change D3 to 1. The value of Q is also 1, as expected. All other inputs are being ignored because we are selecting D3 to be the output. That is how 4-to-1 multiplexer works. The same pattern can be used to build larger multiplexer. I'm going to show you in the next sub-circuits. So this one is the 8-to-1 multiplexer, or you can call it short 8-to-1 mux. The circuit has 8 inputs from D0 to D7, 1 output Q, and we have to have 3 selector inputs because 3 bits can count to a value from 0 to 7. The same pattern is implemented with the 8-to-1 multiplexer here. I used 2 4-to-1 muxes and 1 2-to-1 mux to build this 8-to-1 multiplexer. This 4-to-1 mux, select one from the 4 input, D0, D1, D2, D3. This 4-to-1, select from D4 to D7 based on the value of S1 and S0. And the final one, this 2-to-1 mux, select the value from this output Q and this output Q based on the value of the selected input S2. Right now, the value of the combination S2, S1, S0 is 0. It means that I'm selecting D0 to be the output Q. Change D0 to 1. Q is also changed. All the other inputs are ignored. The output is the value of the selected input. So if I change the selectors to 2, it means that I'm selecting D2 to be my output. D2 right here, 1, then Q is 1. Change it back to 0, when it is 0. Let's change S2 to 1. It means that D6 is my output because 1, 1, 0 is 6. Let's change D6 to 1. The Q is 1 as expected. And that is my 8-to-1 multiplexer. The final circuit for today's video is the mux 4-bit 2-to-1. The name of the circuit is 4-bit numbers 2-to-1 multiplexer. The output and the input now is different from the 2-to-1, the basic one right here. This 2-to-1 multiplexer only select 1 bit input, D1 or D0. But for this circuit, the inputs are 2 4-bit numbers. So we're going to need 4 2-to-1 muxes. Each mux will select one input from the bit of the two numbers. For example, like this selectors, it will select either A3 or B3 based on the value of the selector input S, and the same goes for these three muxes. Right now I'm selecting S is 0. It means that I'm selecting the 0 value of the input of the muxes to be the output. So I'm selecting A3, A2, A1, A0 to be the output. If I change the input, for example, like A3 to 1 and A1 to 1, it means that I'm having 1 0 1 0 at the input, and it is selected to be the output. So Q3, Q2, Q1, Q0 is also 1 0 1 0. If I change the selector input S to 1, it means that I'm selecting the second 4-bit numbers to be the output. And right now the number is 0, so the output is also the same with the selected number. If I change this number to, for example, 0 1 1 0, then the output is also the same with the selected input. That is my 4-bit numbers 2 to 1 multiplexer, and that's it for today's video. Thank you for watching and have a good day.